Hello guys, a very good morning, or I must say, a very good afternoon to everyone. Welcome back to my channel. Just to give you a little context, I think I'm just gonna start a Road to Expert series where I'll be discussing problems and discuss approaches, discuss algorithms and techniques and everything till I reach expert. So, this is the first problem. Okay, let's read it and then we'll try to discuss this. A string A equals A1, A2, AN is called even if it consists of a concatenation joining of strings of length 2 consisting of the same characters. In other words, a string A is even if two conditions are satisfied at the same time. Its length n is even, obviously, and then for all odd I, for all I, for all odd I, that is this thing, and then ai must be equals to ai plus 1 is satisfied. So some example of even strings are given here, and then these are some of the cases which where these strings are not even. And basically the question now asks us, given a string s consisting of lowercase Latin letters, find the minimum number of characters to remove from string s to make it even. The deleted characters do not have to be consecutive. Okay, so basically the problem is actually saying that we need to remove some characters, and then the resulting string should be even, and we need to remove the minimum number of characters. Okay, so this looks like a standard greedy problem, right? The first thing that I think about this problem is that it looks kind of greedy, because we need to minimize an removal of characters, right? So I'll take this sample and then we'll go from here. Okay, so we have this string, let's call this s equals, and then we need to remove some number of characters to make this even. So I'll just write the corresponding indices: 1 2 3 4 5 6 7 and 8. So for all odd I, that is 1 3 5 7, we need to make sure that si is equals to si plus 1. So this is satisfied, this is not satisfied, again this is not satisfied, and this is satisfied. So this has to be satisfied for all odd I in an even string. So we need to remove some letters, right? So if I remove a b, let's say here, and I remove a b from, let's say, here, right? So the resulting string will look as a a a a and b b, because we have removed these letters, right? And now the indices would be 1 2 3 4 5 and 6, and we can see that this is equal, this is equal, and this is equal. And so our answer would be 2 in this case, because we removed two letters from the string s, right? So we need to print the minimum number of strings that minimum number of letters that we need to remove in order to make this a even string, right? So what the first thing that comes to our mind to solve this kind of problem is that, but I'll just write this again. Okay, now see this carefully. If I have something, let's say I have some gibberish over here, some unique letters. Let's say I have a Z, X, C, D, B, A, something like that, and then I have a F, and then I again have some gibberish, and then I have a F again. Okay, so what do you think we need to do in this case for this complete substring? So my point is, if I encountered the same letter twice in an in a substring, will keep expanding as long as uh, we're getting unique characters, and as soon as we get a character which is repeated, so then my point is I could greedily remove all the left part, that is I can just remove this part, and then I can just remove this part, and this will form an even substring, or even string, because this will become as something like that. So this will become ff, right? So my point basically is I'll keep expanding the window. Basically I'm trying to use a sliding window over here, that then I'll keep expanding the window, I'll keep expanding, and as soon as in my map the frequency of any character becomes 2, that means I have encountered a letter which is coming twice, and that would mean that I could remove this whole length minus 2, because we have two characters that are same, right? So I could remove, let's say this is the length, so I could remove length minus 2 letters, and then we can add this to our answer. And then this is again the same sub problem from here itself. So this is done, and then whatever is remaining after this, so let's say A, D, E, G, and A again. So I'll just clear my map. After I have performed this operation, I'll clear my map, and then I'll also start again iterating from this point, and I'll keep expanding the window till I encounter an element such that frequency of any character becomes 2. So this is the length again, and then we can again add this length minus 2 to our res, because these two letters will remain, and we need to remove rest of the letters, right? So this is nothing but length minus 2, right? And then again we can keep doing this for on and on, and then we can keep doing this for on and on, right? Again we can clear the map here, because it might happen that we have already some frequencies stored that will cause issue with this substring, because this substring is completely independent of this one, right? So this is a new sub problem from here, and this will guarantee that we have removed the minimum possible number of characters, because just to prove this by contradiction, it will never happen that if I have encountered something like A, B, C, D, E, G, A, okay, so now this is our substring that contains two letters or two same letters, and then this is never good to keep expanding the window. This is never good. Why do you want to keep expanding the window when you can just keep take this window and then remove this part from it? Why do you have to keep expanding the window? So if we keep expanding the window, this will cause actually unnecessary things. We don't want that. We want to remove as less characters as we possibly can. So we'll stop as soon as we encounter a same element, and this needn't be at the boundary. This can be just at the middle also. So this can be like B, A, C, D, and then G, A, E, something like that, right? So this is a valid subarray, or this is a valid substring. We'll remove this because A has occurred twice, and this is length. So we'll take this length, and then we'll subtract 2 from this. So we'll get all the characters except these two, and then we can remove all the characters, and now this is an even substring, and then we can continue from here to here. I'll give you some time to digest it. I'll advise you to pause this video and then dry run on some samples, and then you'll understand that it is actually never good to keep expanding this window. Why do you want to keep expanding? Because if we can just stop right here as soon as we encountered an element which has frequency 2, so we can just stop right here. Why do we want to keep expanding? Because if we keep expanding, then we'll need to remove more letters, right? So if we take, let's say, this subarray, so this is just bigger than the previous one, and then there's no advantage of picking this over this smaller one, right? So this is essentially it to the problem. We'll just need to implement a basic sliding window. So I have created an operation which will keep track of operation. I have initialized my 2 pointers, then I have a frequency map. So I'll keep expanding the window unless my frequency becomes 2 for some element, then I'll break if it never becomes true, or if it never becomes 2, then that means that I have not encountered any repeating characters. That means I'll have to remove that particular complete substring, right? So this will be j minus I, just j minus I. Otherwise, in other case, I have written this in a simplified way, but we can get the length by j minus I plus 1, and then I could subtract a 2 here. So this will just be j minus I minus 1, right? And then I could clear this map. I could initialize my I equals j plus 1 so that I could continue with my next substring, and then j equals to I, and then we'll handle the next substring, and then we can keep doing this until we go out of bounds, and then we can just print the operations. That's it. I hope you guys got it. It's a fairly simple problem, but the proof is actually not so intuitive, so I'll advise you to think about it for a little while, and then it would be much more clearer. I'll maybe tell you my thinking process, what I was thinking before. I was thinking something like if I have something like a b b, so I was thinking like if these two I'll compare the adjacent elements, and if they do not match, then I'll compare with the next element. If they match, then cool, otherwise we'll just remove this part, the starting part. So here this and this matches, so I'll remove this. Here this and this matches, so I'll remove this. But it might happen that I have something like this. So here this doesn't match and this doesn't match, so if I now remove this, then I'll have to remove this. But instead, if I had removed this AB, then we would have gotten DD. So in just 2 operations, we have gotten our final answer, which is the minimum. So this will not always work. So I thought maybe as soon as we encounter a frequency of 2, that means that this is a varied even substring, and then we can remove all the rest part from it. You can prove this by contradiction also. So this is it. Yeah, thank you guys.